Hi Frank, Bernard Thompson here. Student number 20020038. First off, happy Christmas, happy New Year, hope you had a good one. So just a short video here to give a quick demonstration of my IoT project. I created a mini weather station with the SenseHat on the Raspberry Pi. So have a quick look how it works, the features I've used, and a quick run through the code. So first up, make sure just run it there. So it's just up and running there now. You'll see we have a few log information here. Just logging to make sure everything's working as it should do, or if there's an error, at least I'll know about it. So I started off by creating an account with WIA. Using WIA then to store the weather data from the SenseHat, such as the temperature, the pressure, the humidity. Then on the calculation to get the Fahrenheit and the dew point. So I created 3 graphs, temperature Celsius, temperature Fahrenheit, and dew point. And then I stored the other information just as standard there. Once I had that information, I downloaded a free Bootstrap website template, which had to make a few changes to it in order to display my information. So that's it here. I have this hosted on my own hosting space. So this address is there if you need to look at it. I'll stick that in the README file. So as you can see, we have a carousel run across the top displaying the charts. And underneath them we have the other widgets displaying the weather information. You can see here the values are actually quite high because I have the SenseHat indoors at the moment. I normally have the Tupperware container outside the kitchen window, but I was doing a few checks on this morning. I didn't want to run in and out the kitchen to ensure the SenseHat was displaying the correct message it was supposed to display, so just have it beside me here on the couch. You'll see the map down here. That's just a map created through Google Maps, just showing where the SenseHat is based, so if there was anybody following it, they'd know where the weather is coming from. As well as this, we have a Twitter page here. Click. And I set up a bogey Twitter account because my followers on my own personal Twitter page are getting quite annoyed when they've seen temperature readings coming in the whole time. So in Twitter developer options, I created a small Twitter app as well, which allows me to tweet the weather every 30 minutes. So you can see here, 1 minute ago, it tweeted the current weather for the date and time, temperature, dew point, and humidity. You'll probably see here the time is a bit off for 30 minutes. It's just because I was doing a few checks this morning, so it was starting and stopping the script running. What I also have is if the temperature falls below 10 degrees, it will tweet my personal page from this page. So let's have to log in here now. That one. Oh yeah. So I just check my personal page. And notifications. Here we have it here. So it looks like temperature is down below 10 degrees. It's now 20. Oh, actually, do you know what? I explained this. It is now check if the heating's on or off. I've just changed ThinkSpeak to put it to below 50 degrees just to ensure it work, because I knew inside the house the temperature would be above 10. So that 10 value is just hard programmed in. You'll see that in a second. So that's Twitter interaction. And yeah, that'll bring me to ThinkSpeak next. So I still have 2 reacts, one for temperature, one for dew point. See him here. So if the dew point, if the dew point falls below, I think it's also 5 or 10 degrees, it'll tell you it could be frost, take action. And you can see the other one, temperature. So I just set this back now. As I said, if it's less than 50, set that back to 10. And on the heating, and we can see here, it looks like temperature is falling below 10 degrees Celsius. It is now. That's what the value is at. The day of time, check if the heating is on. Just save that. Yeah, so when that happens, then when I receive the tweet, I open up the Blink app. And in order to turn on the heating, I have a button in there, just press on. Once I press on, the SenseHat illuminates green to simulate that the heating can be turned on. And if I turn it off, just clears the SenseHat. So yeah, I think that's that. So we'll just have a quick look at the code. So website is there, which you might be as interested in. I'm sure you're probably more interested in the network side of things, but if you do, I have everything commented in there of what's going on. So bringing in the relevant style sheets, Twitter section there, the link to the Twitter page, carousel which switches between the graphs, and then the widgets are there and the footer at the end. So my Python script is the wee sense py. A small introduction up here, just stating what it does. Imported the relevant libraries here. Setting variables here, we have green, red, and amber, which will display the color of the text depending on the dew point value, which I'll get to down below. Names and the MAC addresses of people who may be on the network. New sensor object, new WE object, the WE token, and the other tokens down here are for the Twitter page in order to allow me to send tweets every 30 seconds, every 30 minutes, sorry. Then the new Twitter object. I have debugging here basically with logging, just so I can keep an eye on what's happening with the code and what's not happening with the code. So we're basically just saying we're ready to be in. We've signed the variables. We're going to go through the loop. So while through the loop, again, login mess was kind of you're going to see them throughout the program, just at each steps. So we start off by getting the temperature. I had to minus 13 off the value in order to get it some way accurate. Even then, it's probably 1 or 2 degrees out, but it's close. It's close enough. Yeah, for what I'm trying to do, I suppose. Small calculation to calculate Fahrenheit here, multiply the temperature by 1.8, and 11 to it. We get the humidity, we get the pressure, and then we get the tricky one, the dew point. So if you're looking online, the dew point comes from the relative humidity. Yeah, relative humidity, which the sensor on the pie is just humidity. So I've based calculation on the humidity, so it's not entirely accurate. At times it's almost spot on, depending on what the temperature and humidity is. At other times it's off the wall. So I might try to revisit it again to see can I get it some way close to be almost always accurate. So if you see dew point value is a bit like minus 20 and the sun is splitting the rocks out there, it's mild view. What's going on here? That's why. So after we get all the information there, we are creating a connection with ThinkSpeak in order to create the two reacts. So if the temperature or the dew point is below a certain value, I'll be informed of that. Again, we have the log message just telling us that happens. We're scanning the network here for the name and MAC addresses that we saw above. So if the addresses are if either of the addresses are found in the network, this is going to simulate basically a screen in the house. If somebody's at home, every half hour the screen will tell you what the dew point currently is. You can look up and go, okay, that's what it is. So it tells you it's minus 10 to 10, it's pretty dry out, so maybe, I don't know, you might put some balm on the lips or something. If it's between 11 and 12, it's comfortable. It's very comfortable, it's comfortable, somewhat comfortable, quite comfortable, and very uncomfortable. And the color variables that we've done above, as you can see, green is good, amber, bit of a warning, and red is bad. So if there's nobody at home, we log the message, it looks like somebody at home, give the person's name, so me, maybe Bernard, is not home. We then run that function here, the ARP scan. We run the function clear the sensat, just make sure it's not on the sensat. And I put a sleep in here for 5 seconds. The reason why, I found if the temperature is falling below 10 degrees and it was tweeting me, it didn't send out the other tweet of just the weather information every half hour. So put a small sleep in there and it seems to work perfectly. So we get into the tweet weather function. So set the variable here to get the system date and time from the pie. Set the variable Twitter message, the message that's going to be tweeted, so the current weather status, the date, date and time, the temperature, the dew point, whatever else information in there. I think I just have humidity or something there. Yep. Again, try blocks, send it to Twitter, tweet the message, log the information, run that Twitter function then. The function ran. I'm going to sleep every half hour, 100 or 1800 seconds every half hour, and then we're going to go back into that loop and keep running and running and running. So the next piece of code then is our blink. It's very small. Again, assigning the variables that we require. We're going to use the virtual pin 1, color green here. So we're going to do the callback function. And then the if statement here is if it is 1, which is the on state, 1 is the on state value, set it to green. So when I push the button, sensat goes to green, heating is on. Push the button again to turn it off, it's cleared. What I'll do a small video just replicating that. At the moment I don't have a spare camera at the moment, so I'll use the phone to record that and just do a part 2 video just so you have an idea. I tried to do the blink code in Python, but I don't know, I just couldn't manage it. I was trying to follow future tutorials and it was creating more headaches and problems, so I just kind of followed the labs. I used Python for the main script here. Why? Because I've never used Python before. So I wanted just to see basically what it's like and I kind of get a bit of a handle on it and learn a bit. So yeah, I mainly followed the labs here again. I found a lot of tutorials online with weather stations and different things, but I felt like had I followed them I would have just been completely replicating them and copying them. So I basically just tried to do it off the labs and try learning as I go along. The Twitter part, I found a tutorial online that had some of it in it. If I find the link, I'll put it in the README notebook. I'll enable that. And is there anything else I need to add? Let me just think. Yeah. So we see here the log messages coming up when it runs. Yeah, it's log messages. Show the website where the data is being displayed. Read data, so these set to record for every past 24 hours. And ThinkSpeak. Yeah, I think that's everything, Frank. If any questions, reach out to me on Slack, and what I'll do is I'll do a small part 2 video just recording the sensat so you can see the messages displaying across the screen and see how the Blink app works with it as well. So I'll leave it there. Thanks, Frank, and Happy New Year again. Have a good one.
Hi Frank, Brad Thompson here for part 2, so I'm just going to run the program and we can see what's going on with the Pi itself. So the program has started there now. Well, the first thing we should see on the Pi is we should scan the network and see if there's anybody at home. If they are, tell them they're home and we'll show them. So it's saying, Bernard, it's dry. So that's the dew point check. We'll also check see if Nicola's home and do the same check on it. We can see Nicola. I should say this also, it's dry. Good stuff. Frank, I realised I never actually showed turning on off the heating, so we'll have a look at that there now. So here we see, got a message saying it's dropped to 10 degrees, so check if the heating's on. So we'll open the Blink app. Here I can see the heating's off. Look at the Pi, the heating's off, so we're going to turn it on. And the heating is on. Heating's off, on, on. Feel a bit like Homer Simpson. Bell goes up, bell goes down, on, off, on, off. So that's it, Frank. That's everything on the project. So if any questions, reach out to me on Slack and talk to you in the new year. Thanks very much.